And we're live. Okay. So 6, 4, 1. 6, enter, 4, 1, 0. So you're literally just typing it into your calc. 3, 8, 2. Is it then 10 and 0? Alright? Now the initial calculator settings should be set up such that you should be able to do your calculation straight away now. However, I want us to edit the settings slightly, okay? Because there'll be questions out there where we don't just have a list. There'll be questions out there where we have a frequency table. So if you press calc, one var becomes an option. We will press that button shortly. First, I want you to press settings. Under settings, this is the settings I want you to have. When we do a one variable calculation, I want to use list 2 as the frequency. Okay, so if you scroll down to change, at the moment your calculator, without ever changing it, will have 1s as frequencies. And that's fine when it's a list. But when it's a frequency table, we want to put our frequencies into lists. So if you press F2, list number 2. We're going to use list number 2 as our frequencies. Alright? And then it should say list 1, list 2, list 1, list 2, and then 1. We never do a 2 variable calculation, so don't worry about the bottom 3. Alright? There is a use of a 2 variable calculation, but we don't use it. There's no need. Okay? Any questions there? And the reason why I'm recording this example is such that, if you ever want to look at these settings again, also for the benefit of those who don't have graphical calculators yet, you can look back at this setup as well. Yeah, if that's okay? So I'm going to save this recording in our team. Alright? So, press exit. Now, if I press one variable now, it says dimension error. I've not told the calculator the frequencies that I've got. Alright? Because it's just a list, the way that I've set it up, list 2, I just need to say, yes, I have one of those, I have one of those, I have one of those. And some of you thinking, Phil, it's time to defeat the whole object. Trust me, there's questions out there where we have a frequency table where it's important that we have this settings. Alright, we're never going to change our settings ever again now. If for whatever reason you restore factory settings, then you'll have to change them back. Okay? Right, so whether you've got the frequencies on, so those are without graphical calculators. If you haven't got frequencies on, you're okay for now. You'll need frequencies on for when you're doing a group table later on. Yeah? Okay? But for now, you can literally do your one variable calculations. Those without graphical calculators, what you need to do is you need to clear your screen. So AC, all clear. Now that you type your data in, all clear. Alright? And you need to look it up. I think it's shift, so second mode. And then there's like the stat is in yellow above one of the numbers. It might be 4, shift 4. So if you clear it, press AC. So you go back to, if you press AC, then it hit. Alright, so it seems a bit counterintuitive. If you type data in, it's disappeared. If you now press shift, and then 1, because above the 1 it says stat mode, you'll be able to retrieve whatever you want to retrieve. Okay, so X bar will find you mean, S will find you standard deviation. For us with the graphical calculator, here we go, calc 1 var, that again is calc 1 var, if you've already got your 1 var up on the screen already, that's brilliant. Do you agree with 3.77777777? Alright. Yes, you could have done that by adding them all together and divided by 9. But this is so much easier now. You literally type the data in calc 1 var. Not only that, the formula, the nasty formula for standard deviation, don't need to use that. Which of these two do I read out? S. The 3.56, right? Sigma is not a real sigma. The calculator is guessing at what sigma might be. All right? It's kind of doing a little, not continuity correction, it's doing sort of a correction. It's guessing at what sigma might be. S comes from the sample. We type the sample in. There is our sample mean, and there is our S. All right? I know it doesn't ask you to write down X bar, but I want you to get into the routine of writing down X bar automatically. So if you go to your example, calculate the sample standard deviation S. Come on in, you're on it. Those pesky buses. What was that? 3.5. 56. Yeah, 562. I think. Okay. Now the question wants you to be comfortable with variance as well. John's second minute, yeah. Sorry. So the question itself wants the standard deviation. Yes, I encourage you to write down sample mean as good practice because usually they go hand in hand, sample mean and sample standard deviation. It now wants variance. The calculator doesn't give you variance. You just need to, if you ever need it, which we very rarely do, just square it in the calculator. So go to your normal math mode. What is 3.56 squared? So to change modes again, you press the menu button and then go to option 1. Type in the calculation, press enter. Now yes, still, but you know, eventually you'll build up calculation. Just pay attention to the last one. Don't worry about everything else. If that upsets you, if the rest of the calculator calculations upset you, you can always delete everything. You can clear the screen by pressing delete all. Okay? But yeah, don't panic. Just literally do another calculation. Eventually you'll become more comfortable with that. Alright? 3.56 squared. 12.67, I believe. Happy with that? Alright? So variance, it has its purpose. Okay, analysis of variance, which is what, chapter 20. What else does variance have? Its reasonings for technically chapter 5 in the normal, chapter 6, in the normal distribution. Maybe, but usually it's S. Alright, so now that I've shown you how to find S using graphical calculator and also talked you through without, there is another question underneath that I want you to have a go at. Okay, so have a go yourself. I'm going to give you, what, a minute and a half, maybe 2. Try and work out X bar and S following those key presses. Those with the graphical calculator are done now. They're just waiting for those without. If that's not sales pitch, I don't know what it is. Okay, so let's see how we go. 20.4. If you got 20.4 for X bar, it's very likely you got S correct as well. Alright, make sure you even got S, not sigma. So it's not the 10.5, it's the 11.1. Yeah, the question actually wanted for variance as well, so don't forget square root of this, square that as well. There's that. Okay? So you have the capabilities of working out not just S, but X bar as well. The reason we've worked out variance is therefore you are aware that variance is standard deviation squared. Here's a question for you. There will be chapters where some of the distributional analysis won't give us S straight away. It might actually give us S squared. It might give us the variance. So my question is, I know it's a simple answer, how do we work back from variance back to standard deviation? Just square root, just won't do that. Alright? So standard deviation, just a nice little reminder, is the square root of variance. Okay? So when we get there, in those situations where we've been given variance instead, just remember to square root your variance. Okay? For standard deviation. Lovely. Alright? Now that's all well and good. If we have a small data set, type into the calculator, done. What if it's a larger data set and let's say the person who's collected the data and has it in a spreadsheet forgot to press the simple button of working out an average, right? Or forgot how to do the calculation on a spreadsheet. Equals average this reference. Equals standard deviation this reference. But they remembered that it has something to do with sums. What if we have to use formulae, summary statistics, sigma notation statistics? Okay? Now there's two formulas. There's one involving x minus x bar squared. Alright, this here tends to be the old AQA spec type question. Alright? We are not AQA anymore. Alright? AQA decided to give up on the A-level statistics. Therefore, the government said to Edexcel, come on, can you guys have a go? Yeah, AQA didn't want to make it harder. So they gave up. So Edexcel were basically forced by Ofqual. Come on, you make an A-level statistics. That's actually, difficult in comparison to what it used to be. It used to be great. I mean, it used to be easy. It used to be easy having the 6 modules. Yeah, I could train an absolute, just literally, if you got a monkey from the zoo, I could train it to get a B in the old spec. Very easy. But yeah, now that we're on Excel, this is not just the only difference they made. There were other differences as well. It's in the style of the question. Yeah, AQA was very applied as technique. Well done, you remembered that technique. Full marks. Whereas at Excel, it's now a case of identify the correct technique, apply the technique correctly, and then understood what you actually did. There's a lot more going on, yeah? But yeah, don't panic. I've got ways of helping you remember that, okay? Like I said, we'll have the course done easily before Easter, yeah, which gives us 2 months of revising everything together. All right, the sooner we get finished, the more revision we do. It's this here, that tends to be the type of question we face. Okay? Now, you've got to be careful, depending on what type of summary statistic you've been given. If it is sigma x minus x bar squared, you just use that and done. Students try and overcomplicate it when they're being forced to use this second one. Alright? Whereas the first one, you need to be given both sigma x. Notice how sigma x also appears in the mean formula as well. Need to learn, need to know. NTK, that's our first NTK, our first need to know. Whenever I put NTK next to a formula, it means that you've got to remember it. Okay? You won't find that formula in the formula. You have to remember it. If you are looking for a list of all NTKs, that can be found on Connect. On Connect, front page, you've got how to submit via a PDF on Connect. Underneath that video, you have 3 links. First one, form booklet. Underneath that, list of need to knows. And then the third one is the spec. It's content breakdown. So if you're interested in how to organise folders, chapters 1 to 21, that's the place to look. Okay? So that's how we go. Yeah? Whenever I put FB, formula booklet, that's written. Alright, so NTK for me, you'll find standard deviation formulas in the formula booklet. Example number 1. Notice the one we've been given. The one we've been given is the older style of question. Now, students say, Phil, why do we do it then? If it's on the old spec, why do we still do it? Because if I was an examiner and I found there was a formula in the form booklet for your exam, I could actually set you the question on any formula that's in the form booklet. Alright? So in theory, they could still ask for this format. Okay? Yeah? Mean is an NTK. Need to know. The more you write this formula down, the more you're going to remember it. Sigma x over n, easy enough. 35,000 over 200. On average, a zebra weighs 175 kilograms. Kilograms. Which is about what? Almost 400 pounds. It's good to know that I am half the weight of a zebra. Yeah? 2 fills make a zebra. Yeah?
They're not very heavy.
They're not very heavy, are they? No, they're not very heavy. No, thanks for saying that. Cheers, thanks. Make me feel better about myself. 2 fills, you're not very heavy. Good, good, good. But you think, given the size of a zebra, alright, you think, oh, alright? Using the form booklet, the one we want, S, given the type of summary statistic that's been given, both formulas involve square root 1 over n minus 1 times by something. If it's the sigma x squared, we have a bracket sigma x squared minus sigma x whole squared over n. The one we've been given is actually a little bit easier, because they've done most of the analysis for us. So all we've got to do is sub that value here. All we've got to do is sub that single value there. Alright? No subtraction, no squaring, no summing. They've already worked out what that sum of squares already is. Does that make sense? Alright, so literally, that whole component gets replaced with that one value. I've seen students try and overcomplicate it. The whole of that sigma gets replaced. Okay? What was n? N was 200? Yeah? 1 less than 200? 199 times by sigma of x minus x bar all squared. The whole of that sum, the whole of that sigma gets replaced with the value 8500. Do you want to try some 19 cal? It'll be about 6 point something. .54. It goes 535, which rounds up to 3 significant figures. 6.54. All right, does that make sense? So you could, if you wanted to, type in 1 over 200 minus 1, but it's easy enough for you guys to subtract 1 yourself. So 1 over 199 times by 8500, all underneath the square root, comes out to 6.54. All right, so that's an example of the old style. Let's have a look at the new style. Anyone still need that? Speak now from hold your peace. 6.54 for S there. N is 20. We've been given summary statistics as well. Notice it's the new style where we end up using sigma x as well. Alright, so the standard deviation formula actually used sigma x as well as sigma x squared. Mean. It's a need to know. Do you agree? 15.8. Yeah, so if you were to get a ruler and measure an owl, measure it wingtip to wingtip, notice it's an owlet. Owlet is like offspring of an owl. So if you're thinking, crikey, owls have bigger wingspan than that, it's because it's a kiddie owl, alright? So around about there.
Oh, look at the little baby wingspan. Oh, it's so cute. Oh, yeah, it's so cute. Oh, yeah,
It's alright, they grow up, and they end up getting, abracadabra, when you're flying on your broomstick, so don't get too attached. Sorry, we finally introduced the last, that we finally got to Deathly Hallows with Luke this weekend, so that's me just a little bit upset about Heckler last night. It's okay. Any questions on me? Standard deviation. Now, look at the formulas on above our previous page. We don't need to remember it's in the formula book. And the one we're going to use is the one which involves sigma x squared. It also involves sigma x as well. Both involve 1 over square root n minus 1. This one has a big bracket, so this one's a little bit more complicated to work out because we've got to sub in 2 summary statistics. Sigma x squared goes here. We also sub in sigma x again. We're going to square it over it. That's the first formula we see. That's the first formula we use. Does that make sense? Are you happy with the difference between the two? Trying to identify when to use either one. That's the key thing. So the 5078, we tend to lead off with a bigger number. If 20 is the sample size, take them out. 316 gets squared over 20. When you type that into your calculator, make sure you don't square the whole fraction. Make sure you square just the 316. So you can use the fraction button, and you can type 316 on the numerator and press the square before scrolling across. Yeah? Square root, fraction button, 1 over 20 minus 1, so 1 over 19, scroll across, open up a bracket, the 5078 minus, set up another fraction, 316 squared over 20 again. Scroll across, end bracket. Do you agree with 2.11? Your standard deviation should come up with a smaller number than your mean. If you end up with a number bigger than your mean, something's gone wrong. Alright? It can happen, and later on in the course, we'll see situations where that happens, and hopefully you'll question me, hang on Phil, you said standard deviation will always be smaller than mean. Okay? So that's me to put a little caveat. We'll come across a situation and I'll explain why it makes sense. Alright, but for now, 2.12. 2.12. Yeah? Is there a set of questions for you guys to have a go at, or do I need to find some? I think I need to find some, don't I? Yeah? Yeah, I do. Right, there's your first question. Okay? So, what is x bar and what is s? So, this is what my calculator screen looked like after I typed in a big data set. Notice the sample size is 151. Given that sigma x is 1480 and sigma x squared, which also your calculator gives you, is 15,666. What are the missing blanks? What is x bar and what is s?